This is for Year 12 methods. It's 4D question number 16, which is an explanation of the rational root theorem. We use the rational root theorem whenever I can't find a factor that's got whole numbers. So I'm looking for p of a fraction. And there's a system of trying to find those fractions. Okay, so I'm saying that beta x plus alpha is a factor. Therefore, beta x plus alpha is a factor. So if that's the case, p of minus alpha on beta is equal to 0. So it's alpha divided by beta. Alpha and beta only have a common factor of 1, and beta divides into an, where an is the leading term. So beta divides into 12. So beta can be 1, 2, 3, 4, 6, or 12. They're all the numbers that go into 12. And alpha divides into negative 6. So 1, 2, 3, 5, 2, 3, and 6. So what are all the alpha over betas that I can have? I'll start with 1. So 1 over 1 is 1, so that's already tested. 1 over 2 is a half. 1 over 3 is a third. 1 over 4, 1 on 6 and 1 on 12. Using the 2 on 1 is 2, 2 on 2 isn't relatively prime because 2 divides into them. 2 on 3, 2 on 4 is the same as a half, 2 on 6 is the same as a third, 2 on 12 is the same as a sixth, and I've already got those. I can do 3 on 2, not 3 on 3, 3 on 4, not 3 on 6, not 3 on 12, and 6 on 1, 2, 3 are all whole numbers. 6 on 4 is the same as 3 on 2, 6 on 6 is 1, and 6 on 12 is a half. So my factors must be part of these. So I've done alpha divided by beta. Also I'll consider the negatives. So I'm going to try with p of a half. And p of a half will be 12 times a half cubed, which is 12 divided by 8, plus 20 times a half squared, which is 20 divided by 4, minus a half minus 6, which gives me 3 on 2 plus 5 minus a half minus 6, and that is 6 and a half minus 6 and a half equals 0. Beauty. P of a half equals 0. Therefore, x minus a half is a factor, or 2x minus 1 is a factor. I'm going to divide by 2x minus 1. So I've got 12x cubed plus 20x squared minus x minus 6. And I'm going to divide it by 2x minus 1. 2x goes into 12x cubed, 6x squared times. 6x squared times that is 12x cubed minus 6x squared. I subtract the second one from the first. They disappear. 20 plus 6 is 26x squared minus x minus 6. 2x goes into 26x squared plus 13x times. 13x times 2x is 26x squared. 13x times minus 1 is minus 13x. I'm going to subtract the second one from the first. My x squareds sum to 0. Minus x plus 13 is 12x minus 6. 2x goes into 12x plus 6 times. 6 times 2x is 12x. 6 times minus 1 is minus 6. Subtract the second one, I get 0. So 6x squared plus 13x plus 6 can be factorised with 3x and 2x to give 6x squared. 6 and 1 is no good. 3 and 2 is good. If I put the 3 down there, that gives me 9x. And the 2 up there, that gives me 4x. add them together I get 13x, which is what I want. So I've got 3x plus 2, 2x plus 3, and 2x minus 1, which means the solutions are x equals minus 2/3, minus 3 on 2, and a half. Notice that none of my solutions were whole numbers, and that the 2/3 and the 3/2 were also numbers that were obtained using the rational root theorem. The question says factorise. So my answer will be that they're the factors.